thank you. Thank you for hosting me and James today. So we'll be happy to share today how Microsoft Defender for Cloud enhance container security through the supply chain. And we'll cover the challenges of ensuring security of cloud-native applications and understanding principles of software supply chain, container security, and DevSecOps domains, and hopefully covering in depth on how Microsoft Defender for Cloud address those challenges and protecting our customers' containers from code to runtime. And I'm Beatriss, Kovernaig, and together with me, James Brotsos, and we are both principal product managers from Microsoft Defender for Cloud. Thank you for hosting us today. Well, this visual represents the complex and evolving landscape of modern cloud-native applications architecture. Remember, once it was quite simple. You have one monolith with huge pile of code. Now it's a mosaic of technologies, environments, and deployment targets. R&D teams today have the freedom of mixing different programming languages in same application. So each microservice out of your cloud native application might use a different language based on your team and team members' preferences or legacy constraints. And cloud native apps are also composed by a variety of artifacts. It's not only you're writing the whole code, right? You can find their source code and APIs and AI models, infrastructure as code configurations, and even compiled binaries or scripts. So a single application deployment may consist of containers, serverless functions, packages, both commercial, in-house, and open source, VM images, you name it. Quite a mess. And when you are about to deploy your application into your deployment targets are equally fragmented. Some services are deployed on Kubernetes clusters. There are managed and unmanaged Kubernetes clusters. Some are deployed as serverless platforms over VMs on specialized AI hosting environments. The complexity only grows when you add to this pile also the multi-cloud or the hybrid scenarios. And this is the reality of modern cloud native development. It's highly distributed, technologically diverse, and deeply fragmented. The challenge for the teams today is not just to build the application, but to coordinate, secure, and monitor across all of this complexity. So today, we would dive into container security challenges and how it's been addressed by Microsoft Defender for Cloud. But let's align on some concepts first. So, some supply chain. You probably heard the buzzword, right? This concept becoming central in both software engineering, DevOps, cybersecurity. Well, just like physical goods has their own supply chain, so are software as well. But instead of raw materials and factories, it's composed of code and open source libraries, dependencies, CI/CD pipelines. At a high level, the software supply chain includes all the steps and components involved in building, packaging, and delivering software, from development to build automation, to shipment, into a centralized repository, to deployment and execution. During the code phase, a source code has been written and a third-party dependencies of our software being defined. During the build phase, this source code that I wrote as a developer is compiled and packaged into deliverable artifacts with all those third-party dependencies defined. Container images, packaged applications, serializable AI models, everything. Then during the ship phase, deliverable software artifacts being signed and stored in a centralized artifact repositories, ready for delivery. And upon deployment phase, software artifacts being assessed for deployment eligibility, and if passed all checks, deployed to the target environments. Then during the runtime phase, finally, deploy software start execution. Quite complex. And each of these phases is a potential point of failure or compromise. A vulnerability in one package or a misconfigured IX script can ripple across your entire environment. This led organizations invest heavily in their software supply chain security, which is the practice of securing all component processes and entities involved in the development, deployment, and distribution of software. But we are here to talk about containers, right? So let's take a quick look at what containers are all about. Why it matters in modern software development. Well, containers are a standard unit of software that package up code and all dependencies so the application runs quickly and smoothly from one computing environment to another. Containers actually solves an age-old problem of, oh, it works on my machine. That sounds familiar? Since everything is bundled inside containers, software runs consistently across all types of environments. It's supposed to run on the developer laptop, same way as it's going to run on the production Kubernetes environment. A container is a complex software artifact because it actually shifts to several different artifact types during his software development lifecycle. Starts its journey as a container script Docker file, then during the build, being compiled into a container image, and then upon deploy, this container image can have multiple instances running into our cluster. Let's try to correlate the risks and findings for remediation. Good luck with that. So how containers application move to the software supply chain from code to running into the production? On code phase, we are starting with a developer who writes or edits some code, drop it in a Docker file on container script. This defines how application should be packaged, including its base OS runtime libraries and configurations. The script is used to generate a container image. This is a snapshot of everything needed to run the application. Essentially, a portable unit of software. Then, during the ship, this container image is being pushed into a centralized container registry, Docker Hub, Azure Container Registry, Amazon SCR, JFrog Artifactory. This is where images are stored, versioned, and made available to be pulled into the deployment environment. Then, during deployment, from the registry, the image is being pulled into a Kubernetes cluster, typically managed via CI/CD pipeline, and scheduled into one of the Kubernetes nodes. Finally, if we bear with us, we reached the runtime and entering the runtime phase. The container image is instantiated. Multiple instances can be instantiated from a single container image. And now they're live running containers. And each of these phases, as part of the container supply chain, is a potential control point and a security checkpoint. So misconfigurations or vulnerabilities at any point from Docker file to runtime can have ripple effect. How attackers can take advantage of the complexity of the container supply chain? Well, at the code phase, attackers often inject malicious code into container images or open source dependency. This can be disguised as a legitimate package or update, which is why dependency hygiene is so important. Then, during build, in the build phase, attackers may compromise the CI/CD pipeline. SolarWinds. This can happen through misconfigured build servers, exposed secrets, or by planting malware into automated workflow. This tactic is particularly dangerous because it allows adversaries to embed malicious artifacts into every build and notice. During ship, where images are already submitted into the centralized container registry, attackers may tamper with images in public or even internal registries if they have the access, replacing them with malicious versions or modifying metadata to bypass checks. This is why it's so important to sign images and verify them for authenticity. During deployment phase, misconfigurations like excessive privilege, exposed ports, or weak network policies can leave Kubernetes cluster vulnerable. Even a small misstep, like running container as root, can open the door to lateral movement or privilege escalation. And then, finally, during runtime, even well-built containers can become targeted as applications itself is vulnerable or exposed. This is why scanning container images is not enough. Scanning containers is not enough. You need to scan continuously and assess for security vulnerabilities or your application software artifacts. Attackers exploit the weakest link, so your container supply chain is only as strong as its most overlooked phase. Organization must build security into every stage: code, build, ship, deploy, and runtime to reduce the attack surface. But why we are focusing on containers? Why all this fuss around containers? First, the containers technology space is booming. It's been projected market size to reach 12.5 billion by 2032. And even today, more than 80% of organizations already using Kubernetes and containerized application in their production. This growth reflects how central containers have become to modern software delivery. So why protection of containers is so critical? Well, there are several reasons. First, modern applications, especially those involving AI and ML, are built on containerized infrastructure. Second, the dependency on CI/CD pipelines become a backdoor for attackers if not secured properly. Unvetted open source dependencies in containers are a huge risk, often pulled in without proper scanning governments. And lastly, regulatory pressure is increasing as the adoption of cloud-native environments is on hypergrowth. So is the attention they're getting by compliance bodies like SOC 2, HIPAA, and others. And if the containers aren't properly secured, the business consequences are severe. Financial and data loss, as well as poor decision made on compromised data. Software supply chain attack, which can propagate malware or tampered images across ecosystem and contaminate not only your organization, but also your customers. Attackers may escape container boundaries, move laterally in cloud environments, and access sensitive systems. And beyond the technical costs, there are legal and reputation damages, fines, lawsuits, and loss of customer trust that's hard to recover from. And if you need more justification on why should we give so much attention to container security, just look at those numbers. 67% of organizations have delayed deployment due to container security concerns. This slows down your organizational innovation and time to market. 87% of container images in production contain critical or high severity vulnerabilities. Compromised organizational at increased risk for breaches. And this outrageous number that in average, every container image has around 600 vulnerabilities. Why such high numbers, you're probably asking? Because secure containers isn't just about tools. It's about keeping up with the extremely fast, fragmented, and ever-changing environment. Organizations are suffering security findings overload, too many alerts, not enough context for prioritization and remediation because you have like hundreds or thousands containers in each of your environment. Containers are ephemeral containers. Containers are being instantiated and then turned down upon demand, meaning you may have a vulnerable container and you generated an alert recommendation, but when you are about to fix it, it's not there anymore. Containers has an immutable nature, meaning it's not as easy as deploying a fix on your deployment environment. You can't just patch it. You need to rebuild and redeploy the images properly. And there's so many teams and processes and tools, that touch containers, the joint ownership between dev, stacks, and ops, which increase gaps. Container knowledge gap is also one of the factors. Many teams are still catching up on containerized best practices, and traditional security tools weren't built for dynamic cloud-native environments. This attack path shows a real-world cluster-to-cloud scenario, when an attacker gains a foothold in a Kubernetes cluster and then moves laterally across cloud environments. The attack starts with a vulnerable container image that's deployed on a pod exposed to the internet. The attacker exploits the vulnerability and gains control over the container. From there, the attacker leverages managed identity credentials to access other resources like Azure Storage Account and even your AWS RDS database, both containing sensitive data. Microsoft Defender for Cloud detects this attack path by correlating insights across multiple signals: internet exposure, image vulnerability assessment, Kubernetes RBAC, and data sensitivity classification. So attackers don't stop at the compromised containers, using them as doors into your organizational assets. Luckily, Microsoft Defender for Cloud delivers end-to-end security across the cloud application lifecycle, from code to runtime, and helps prevent and detect cases exactly like that. Starting from the left, Defender helps developer build securely, identify misconfigurations and vulnerabilities early in code and pipeline. On the right, provides near real-time detection and response for cloud workloads, data, and APIs with a unified SecOps experience. With contextual posture management, we help you prioritize, reduce risk, and remediate continuously, leveraging advanced AI capabilities for threat intelligence and supporting multi-cloud and hybrid environments and beyond. To address the container security challenge, Microsoft offers a comprehensive end-to-end solution with Microsoft Defender for Cloud. We look at container security through critical pillars: protecting the containerized environments in all its development stages, the DevSecOps, getting visibility into the entire Kubernetes estate and offering security best practices with compliance, and finally securing deployed containers while they are running on production. Our solution also caters to all the teams in the organization: engineering, CISO office, security admin, cloud governance, developers, and SOC analysts. So Microsoft Defender for Cloud provides an end-to-end container vulnerability management through the software development lifecycle from code to runtime. Shift left CVX fixes and reduce risk for runtime environments. We start at the CI/CD stage, where defenders use a CLI-based tool that we are going to demonstrate later that integrates with any pipeline to detect image vulnerabilities during build time, helping catch issues before they reach production. Next layer is a container registry. We are continuously scanning centralized container registries, your ACR, ECR, GCR, Docker hubs, and JFrog Artifactory to identify security threats. Defender continuously scans those images for vulnerabilities even after they're built and stored. When images are deployed to AKS, Defender assesses cluster misconfigurations, image and container vulnerabilities, even for running container, and runs gated evaluation before deployment for risk control. All findings are enriched and correlated to Defender vulnerability enrichment layer, which helps map vulnerabilities back to CI/CD pipelines, asset risk, and attack path. Evaluate reachability using the third-party integrations such as Endor Labs and recently announced Mend.io. Finally, security insights can be consumed in various ways, catering for the needs of the different stakeholders across the organization. CISO office can consume the results via the Defender for Cloud portal. Developers can get access to the security insights of the clusters under their responsibility via AKS Security Dashboard or the CLI console during build, and DevOps teams can use our APIs for automation and workflow integration. Microsoft Defender for Cloud brings visibility, enrichment, and actionability into every phase, allowing teams to identify, prioritize, and remediate container risk with precision.
Thanks, Beatriss. That was great. All right, so let's control who we let in, ensuring secure, compliant containers from code all the way to runtime. We scan early for security issues, Shift left scanning baked into repositories and pipelines, catching CVEs and misconfigurations in code or IAC templates before they even become images. No late stage surprises or midnight hotfix marathons. Security gates throughout the whole SDLC, policy guardrails at each pipeline stage automatically approve or block builds that don't meet your standards. So only known good artifacts make it into your registry. Actionable insights for prioritization and remediation. Unified risk dashboards rank findings by exploitability and business impact with clear prescriptive fix steps. And native Defender XDR playbooks speed response once containers are live. With Microsoft Defender for Cloud as your CNAPP backbone, you gain real-time visibility, automated policy enforcement, and smart prioritization, turning a reactive tug of war into a seamless, proactive security flow. Let's dive into DevOps posture visibility, real-time insight across code, dependencies, secrets, container, images, and IAC. Defender for Cloud hooks into Azure DevOps, GitHub, and GitLab, harvesting every repository, pipeline, and template into one unified inventory, so you know exactly where your risks lie before anything hits production. Whether you're on GitHub Actions, Azure Pipelines, or GitLab CI/CD, all your scan results flow into a single DevOps security console. No more siloed dashboards or tool hopping. Every commit, dependency, update, or IAC change triggers an immediate scan for vulnerabilities, misconfigurations, and secret leaks. And Defender for Cloud compares your templates against best practices, helping you bake compliance in as you build. Security findings show up as pull request annotations and code to cloud contextual insights, so developers fix critical issues in their own workflow. All findings feed into DevOps Security Console, your single source of truth. Customize Azure Monitor workbooks to build the dashboards and reports your government's model needs. With this level of visibility, you shift security left, turning late-stage surprises into early, manageable fixes and keeping your container supply chain resilient and compliant. Make your IAC definitions the single source of truth for secure container development deployments. Embed policy guardrails built on Azure security benchmarks directly into your ARM, Bicep, Helm, CloudFormation, and Terraform templates, so secure defaults travel with every commit, not as an afterthought. Defender for Cloud's IAC scanning via the template analyzer, Chekhov, or Terrascan automatically finds misconfigurations in your templates before they even reach the pipeline. Out of the box, your templates are evaluated against the Microsoft Cloud Security Benchmarks controls, surfacing policy violations as inline recommendations. Pull request annotations pinpoint the exact template line and parameter that violate a control, giving your team crystal clear context for fast, precise fixes. Every IAC finding includes prescriptive remediation steps and can even trigger Security Copilot generated PRs to autocorrect misconfigurations so engineers spend less time hunting risks. Whether you're using ARM or Bicep in Azure, CloudFormation in AWS, or Terraform, and Helm everywhere, Defender for Cloud covers them all, giving you one consistent IAC security posture across every environment. By shifting IAC security left, you bake compliance and best practices into your infrastructure definitions, keeping containers safe from the very first line of code to production runtime. Failures have consequences, so we fail insecure builds. Microsoft Security DevOps integrates into your CI/CD, Azure DevOps or GitHub Actions, and breaks the build on high-risk vulnerabilities or misconfigurations, shifting security left so only vented artifacts advance. Defender for Containers plugs into your AKS clusters via Azure policy and gated deployment, auditing each Helm chart or manifest against sys benchmarks and custom policies with audit-only mode or outright blocking of non-compliant deployments. Under the hood, Defender generates a vulnerability findings artifact for every image scan and applies security rules at admission time. In deny mode, any pod spec referencing an image with critical CVEs is rejected at the API server, so insecure containers never land on your nodes, and your SOC team gets instant alerts in Defender XDR. By embedding these security gates throughout the SDLC, Defender for Cloud CNAPP architecture ties dev and SecOps together in a unified automated enforcement model that stops risky code before it ever reaches runtime. So the Defender for Cloud CLI, this tool has been battle tested in the wild. It has over 1.2 downloads on NuGet alone, so teams from startups to enterprise already rely on it. It orchestrates a full set of security scanners, anti-malware, Bandit, BinSkim, Checkov, ESLint, IAC file scanner, template analyzer, Terrascan, and Trivy. So you only run one tool instead of juggling 8 installs, keeping your build steps tidy and reliable. Embedded seamlessly into any CI/CD pipeline, Azure DevOps via the MSDO extension, GitHub Actions with the security DevOps action, and we also support non-Microsoft tools such as Jenkins, Bitbucket pipelines, Google Cloud Build, Bamboo, Circle CI, Travis CI, TeamCity, Oracle DevOps, and AWS CoBuild. It just runs as another pipeline step, so you don't have to download or install custom plugins. Authentication uses immutable API tokens from the Defender Cloud's integrations page. So your CI agent pushes results securely, no interactive logins, no leak creds. And once the scan completes, the CLI pushes the serif formatted findings into Defender for Cloud. It fuels posture analysis, analytics, attack path mapping, containers of pipeline correlation, and unified code to cloud visibility in the Cloud Security Explorer. Whether you're running a quick local scan on your laptop or powering thousands of production builds, the Defender CLI delivers consistent automated checks to safeguard your container supply chain at every stage of DevOps. We update vulnerability assessment findings file with each scan and attach it to the image in your registry, making vulnerability data inseparable from the artifact. Each VA artifact carries a Microsoft signature, ensuring scan results are tamper-proof and audit-ready. VA rules sync to the cluster in real time via the Azure Policy add-on for AKS and the Kubernetes emission controller, giving you guardrails that evolve with your policies. You choose audit or deny mode with policy gates that either log non-compliant images or block them outright at emission. So only vetted containers ever run. Monitor emission event history in the Defender for Cloud emission event history blade gives your SecOps team a clear, searchable audit trail. Think of it as turning your AKS cluster into a zero-trust runway, where no image taxis until it's cleared every security checkpoint, minus the TSA packdowns. Defender for Cloud enriches every finding with live threat intelligence, CVSS scores, exploitability metrics, breach likelihood models, and maps it into your cloud security graph. So you can instantly see which vulnerabilities attackers could reach from the internet through your VMs down to individual containers. We build a unified graph linking exposed endpoints, cloud resources, nodes, pods, and containers, overlaying the CVEs and misconfigurations and any secret accidentally checked into your code or IC templates. You can think of it as APIs or passwords. API keys or passwords. And every alert shows exact file path, the line number, and git commit where a vulnerability or secret was found, with prescriptive remediation steps to rotate credentials, patch libraries, or correct configurations, so developers fix issues in line in daily workflows. The AKS Security Dashboard brings it all together, visualizing attack paths, flagging exposed secrets and open source flaws, and letting admins drill from internet exposed resources down to the defending code line. By combining exploitable context, a rich environment graph, and direct code level traceability, Defender turns raw data into prioritized, actionable insights so you are secure your supply chain with confidence and clarity instead of chasing noise. Defender for Containers inventories all running workloads across any registry. So Azure ACR, Docker Hub, AWS ECR, GCR, or private registries, continuously mapping live images to up-to-date CVE findings, so you always know what's on your cluster and where it came from. Agentless host and container scanning kicks in without sensors or agents, using out-of-band disk snapshot scans to keep performance pristine. You get full CVE coverage across the custom app images, AKS add-ons, and third-party services with contextual remediation steps, so you know exactly how to fix issues. No runtime surprises. Continuous monitoring and SOC learning means assessments run in every image pool on a regular schedule, updating VA findings attached to that each image. Detected CVEs and malware findings generate security alerts with CVE IDs and prescriptive fixes that feed directly into your SOC dashboards for rapid triage and response, eliminating blind spots. By embedding these runtime vulnerability assessments from host through container into your supply chain, Defender ensures proactive, continuous protection and clear, actionable guidance, letting your security team relax. Almost. In a shared responsibility model, Microsoft patches the VM images from your AKS node pools while you control node configuration, updates, and upgrades to meet your app requirements. No agents, no network tunnels, no performance trade-offs. Defender for Cloud takes periodic snapshots of your node disks, spins up isolated, short-lived scans in the same region, then deletes everything, leaving your nodes untouched and humming at full speed. Okay, so imagine daily zero config vulnerability management assessments that crawl OS and language packages on your node VMs, surface known CVEs with exploitable context, and digitally sign each finding so you know it's authentic. Defender for Containers then generates prioritized recommendations with concrete remediation steps, so your team fixes issues before they become headline-making breaches. Layer in agentless malware detection powered by Defender Antivirus, scanning snapshots for malicious files or processes, and pushing alerts directly into Defender and XDR dashboards. Combined shared responsibility, agentless architecture, deep vulnerability insights, and robust malware scans turns your container supply chain into a resilient powerhouse that scales with confidence so you can focus on innovation and not investigation. Defender for Cloud ingests DevOps security findings, IAC misconfigurations, open source vulnerabilities, and exposed secrets, and weaves them into our intelligent cloud security graph, giving you one unified view of how code level risks map to runtime assets and potential attack paths. We prioritize critical issues for correlating CVEs and leak credentials with environmental context, with internet exposure, or lateral movement potential, so you can focus on hotspots that pose real business risks instead of chasing every low severity nitpick. Drive remediation and code with custom workflows that auto-assign findings to the right developer, while SecOps kicks off pull request annotations with prescriptive fixed guidance directly inside the pull request. Think of inline security coaching. With code-to-cloud contextualization, you transform raw scan data into prioritized, actionable insights, bridging dev and SecOps into one smooth, proactive security flow that safeguards your container supply chain from the very first commit to production runtime. Okay, in my last slide, this is the AKS portal powered by Defender for Cloud. Workload owners stay in their familiar cluster blade, no console hopping needed. Under the Vulnerability Assessment tab, you see all the CVEs flagged against your container images and AKS infrastructure, no pools, control plane add-ons, complete with CVSS scores and remediation steps that upgrading your image or patching your base image. The Misconfigurations tab highlights deviations from best practices, pod specs, to RBAC settings, each with guided remediation or a one-click fix to restore your secure baseline. With Defender CSPM, DCSPM enabled, built-in policies Azure security benchmarks, SIS, custom standards, surface compliance gaps in real time, so you prioritize policy failures along CVEs and misconfigs. Integrated threat analytics, feed alerts, malware, malicious API calls, suspicious processes into the dashboard, giving your SOC or platform team immediate runtime visibility without ever leaving AKS. This one pane of glass dashboard delivers exactly the security context you need right where you work so you can detect, prioritize, and remediate issues faster, keeping your container supply chain resilient and compliant.
So it's demo time. Thank you, James. Well, I hope that we convinced you that Microsoft Defender for Cloud provides a comprehensive solution to secure your containers, software supply chain security. And I would really love to showcase it in action. Aha, no, not. Oh, obviously, not the right. This one. Yay. Let's roll the demo. So, what I'm about to present is the combination of two of the capabilities that we touched during the presentation, both recently announced. We have our CLI that provides the ability to scan pipeline agnostic during the build phase, pluggable into any CI/CD pipeline vendor of your choice. We're going to demo it on Jenkins, but it's not limited to Jenkins, of course. And the second capability that James was introducing, which is the gated deployment ability to attestate container images just a second before they are becoming running containers on your production environments. Both of those security guardrails are best practices, for any organization willing, to detect the security findings, shift left as possible early in the software supply chain process, and definitely protect the deployment phase as it's, like your last chance, catching the vulnerable image just before it's being deployed. So Microsoft Defender for Cloud, as you saw, scans containers applications across each stage. We are scanning them. We are providing capabilities to scan them with the CLI during build. We are scanning them continuously whenever you are pushing them into your container registry, and then we are accessing the container images for security threats just before they're about to be deployed to the AKS cluster. And then during runtime, we are continuously scanning them and accessing the running containers for live threats. Here we can see the artifact that James introduced. This during the scanning phase, we are creating an artifact that contains scanning results, same scanning results you can consume from the MDC application. That's been packaged as an additional artifact in our Microsoft proprietary format, being associated with the container itself. Here you can see the example of such an artifact. Pay attention to the digest. The SHA digest is important. We are going to trace this container image along the way. Here we can see that security findings file it can be found via the reference tab and obtained via the digest ID. So we run ORAS to fetch an example finding file, and here you can see we have all the information, all the important information resulted in Microsoft Defender for Cloud container security scan. We have there the full artifacts result, information such as CWIDs, leading severity scores, evidence that shows the type, path, and layer ID, as well as the reference URLs, and a CVAD vulnerability package, and even the fake version. So why we are generating those findings? Because those findings generated upon the push of your container image into the container registry is being generated based on the results of our vulnerability assessment scanner, signed for authenticity and associated with the container image. And later in the phase, during the deployment phase, we are evaluating the container image eligibility for deployment based on the security rules defined for the context of the cluster and this associated findings file. So here we have a Jenkins pipeline that shows all stages a container's application would go through, from building the image to deploying to the AKS cluster. In the pipeline itself, we can see that using the CLI, we are able to detect vulnerabilities. Here we run the RCLI, and we can see the results that can be consumed, as James mentioned, in the context of our Jenkins build. No need to go to the portal. And as a developer, I'll probably would like to get the results in the context that I'll constantly working with, either run it on my laptop or from my IDE, or to identify security threats found, security vulnerability found as part of the artifact that I'm responsible for during the build phase. So we see that we found various vulnerabilities, and we are trying to deploy our image to the AKS, and the deployment failed with a detailed warning saying, well, you have a webhook and you have an audit security violation. There are two types of actions security policies may have, either audit or deny. Audit is not going to block the actual deployment, but it's going to alert us that you attempted to deploy an image that violated the organizational security policy. And we can also see the result as an enrichment on our container on a recommendation. And there is the deny action, and the deny action is actually going to prevent the deployment. So we can see that we have a warning saying, oh, we didn't stop the deployment, but your image actually violated the organizational security policy. And for the one that didn't have the opportunity to play with the gated deployment feature, extremely recommending it. And not only because I'm the product manager leading this feature, but I really think that it's a great addition to Microsoft Defender for Cloud. Here we can see under the security rules, we have the gated deployment policy, where we can see under vulnerability assessment preview all the instances of the vulnerability assessment rules, more types that would follow, but I'm not going to disclose which ones. You can raise suggestions and asks. And there is an extremely important screen, which is the admission monitoring. Admission monitoring screen logs all the events, audit or deny, for all the policy matches whatsoever. And here we can see our the rule that we have defined with an action of audit. This is our rule, the rule that triggered the warning. And it's defined for a scope of a whole Azure subscription. We can add additional filters. We can define it, narrow it to a certain cluster name or even a namespace. And if I'm reviewing the configuration tab, I can see the conditions, meaning that this rule is going to alert on any container image being deployed having high and critical vulnerabilities. And if I want to see the actual rules configuration inside my cluster, I can reassure you that any change to the rule configuration would trigger a new real-time update. We have a dedicated file named security audit policy, and we can see here that we have a rule of type audit. Here is our KubeCon demo rule that limiting in terms of severity, limiting any vulnerabilities having at least a high security score. There are additional conditions that we just don't have enough time to show, but you can block a specific CV, you can build a combination of both threshold policy and specific CVs, and you can exclude CVs from this condition as well. Cool. So we saw the audit in action. So audit didn't prevent it, but it did generate a warning in our console, and it's also generated an event. And here is our audit event. As I promised, all the events are both audit and deny are being logged for further investigation. We can see that we have, the image digest of the image that generated the event. We have the description. We are pinpointing the violation itself. We have the rule name, timestamp when the event occurred, the action, and description of what exactly happened here. The snapshot of the parameters of the configuration of the rule. Cool. Now let's try to change the policy to in deny mode and see what would happen. So I'm changing my action to deny. No changes there. I got the change for my subscription. I am approving the change. Voila. And we can go to the policy configuration file and reassure that you can see that our action changed into deny. Okay, and what's going to happen now? We are going to try and attempt redeploying our container image. Let's run so everything is running. Okay, so believe me that it would run until yes, we are here. We are running with the CLI, the scanning once again, and just trying to gain us more time. Ooh. Yay, and we are trying to deploy it. Yes, trying to deploy to the AKS. And the deployment failed. Why the deployment failed? And this case, now we have an error from the server then we are violating security policy and we are denied for the deployment request because we have the following violation. And we also got the deny event. So those are gating capabilities for the gated deployment. Of course, we shouldn't, reach the deployment in the first place, right? We should stop our vulnerable image in the CLI phase, and this is in the build phase, and this is actually can be done with the CLI. If you can see here, we have one of the parameters of the CLI is the not break on detections flag. And if we are going to remove the not break on detection flag, then we are actually going to break the build on a policy, just integrating RCLI as part of your build pipeline. And here we are putting it in a comment and rerunning it. Here. Jump to the important part. Okay. Run Trivi. Yes, and we didn't reach even the deployment because we did a break build, and we actually stopped this vulnerable image when it was supposed to happen initially during build, but of course it's not instead of the gated deployment. You need both guardrails to be applied. Yay. Questions? I think it's questions time.
Perfect. Thanks, Beatrice. And it actually looks like all of our questions were answered in the chat already. So thank you so much to Beatrice and James for being our guests and for sharing the great information with our community. Also, thank you to the Q&A team who helped us with answering the questions and providing the resourceful information. To all the listeners still on the line, if you're someone who wishes to aid in the protection of the world from cyber threats and desire to have a say in shaping our strategies, blueprints, and recommendations, then we invite you to become part of our security community. Together, we can make a global impact. So join us at aka.ms/securitycommunity. This is also where you'll be notified about the upcoming webinars, events, and other announcements. For those of you who may have additional questions on the topic we just covered or other product-related questions, please feel free to raise them on our Microsoft Tech Community discussion space at aka.ms/MDC community. Thank you all for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.